Hello class, welcome to this video on lesson 10.2 practice, part 1. So we're going to look at the first couple of questions in these in the exercises. So number 1, college financial aid offices expect students to use summer earnings to help pay for college. But how large are these earnings? One large university studied this question by asking a random sample of 1,296 students who had summer jobs how much they earned. The financial aid office separated the responses into two groups based on gender, so these can be viewed as independent samples. Here are the data in summary form. Okay, so they give us the data in summary form. So they give us the sample size, they give us the sample mean, and then the sample standard deviation. How can you tell from the summary statistics that the distribution of earnings in each group is strongly skewed to the right? The use of sample T procedures is still justified, and why? So let's look at it. Based on the data, you can see, okay, well, the average is 1,884, and the standard deviation is extremely high. So, and it's almost as much as the mean. It's not that far off from the mean. So remember what the standard deviation means. The standard deviation means that the average distance from the data points to the x-bar is 1,300. That means the data is very, very far away on average from the average, right? And notice that if it's very far away, so let's say this is the x-bar, it's saying that the data is on average very far away from that. However, we know that it could be far away on the right side or the left side. However, because the value of the standard deviation is 1,368, we know that the data can't be that much on the left side, because if it was that much on the left side, you would reach into the negatives, right? And so we don't want any negative values for earnings. That wouldn't make any sense. Therefore, it seems like most of the data, or a good chunk of the data, or you're going to have some extreme values more on the right side than on the left side. And so you would have something that looks kind of like this, where you can only go so far here, right? Because it's you don't want to get past 0, and then you have a lot of numbers. The sky's the limit, really, as far as earnings. I would say on the right side. And therefore, because the standard deviation is so large, it appears that the data is going to be skewed to the right, okay? So we're going to say, it says, how can we tell it's skewed to the right? So we can say the standard deviation, and it's the same for both of them. The standard deviation is pretty large. So it's very large for both samples and close to the mean value, to the sample mean values. Since earnings can't be negative, this means the data has to be skewed, has to be strongly skewed to the right. Okay, so that's how we can tell. And then the use of sample T procedures is still justified. So why can we still use the T? Well, we can use the T, the two sample T procedures, because the shape, even though the shape is strongly skewed, we have a large enough sample size. We can still use two sample T because both sample sizes are large enough. Meaning greater than or equal to 30. Okay, so now let's construct and interpret a 90% confidence interval for the difference between the true mean summer earnings of male and female students. So again, we're going to do the state So what are we trying to construct? We're trying to do a 90% confidence interval for mu1 minus mu2. We're trying to do it for two different averages, right? And we're doing two independent samples. They said they're independent, which means that we're doing the difference between those, and it's, we're not doing paired differences or anything like that. We're looking at two independent samples and then just looking at their data. So we have 90% confidence interval for mu1 minus mu2, where where mu1 is equal to the true mean. In this case, we're going to do the male, so summer earnings. Summer earnings of male students. And mu2 equals true mean summer earnings of female students. Okay, and there's our state. Now we're going to do the plan. So what's our plan? We're doing a 2-sample T interval for mu1 minus mu2. And then we're going to look at the conditions, right? So what are the conditions? So we're going to look at the random condition first. Remember, for the random condition, you have to state that the two samples are independent, okay? So again, they already mentioned that they're independent, okay? So we have two independent random samples of male and female students. All right, and then they're independent because knowing male responses will not influence female responses. Now you can put this as an extra detail. It's not really necessary because they mentioned in the problem that they were independent anyways. But I did want to include that there just to be, just to clarify. All right, so 10% condition. We have that the first sample is 675, which is less than 10%. We can assume it's less than 10% of all male students. At the university. And N2 equals 621, which is less than 10% of all female students. At the university. Okay, there's a 10%. And so now we're going to do and then conclude. Oh, we forgot to do the normal. Let me do the normal sample. Sorry about that. There's one more condition. Normal or large sample. Okay, so the normal or large sample condition, is the sample size large enough? Yes. N1 is greater than or equal to 30, and N2 is greater than or equal to 30. Okay, so it checks that off. Now we can do, we're going to calculate. Okay, so now we need to, we're going to use the calculator option 1, but I'm also going to show you, I'm going to show you both options. I'm going to show you option 1, and then I'm going to show you option 2. Okay, so let me show you both of those. So for option 1, Let me see. So I'll do option 1 here. Again, you only have to do one of these, but I'm going to do both of them for you. Now, option 1, you're going to use the calculator to determine, to determine the degrees of freedom, and then to calculate the interval for you. Okay, so we're going to show you how to do that. All right, so we're going to show you how to do this on the calculator for option 1. So we have second. We're going to hit, or actually, we don't need to hit second. We're going to hit stat, and then go to tests. And we're going to go down to 2 sample t interval. Remember, we're using t for this. And then we're going to go to stats because we already know the statistics. They gave us the X bars and all that. Okay, so the X bar for males is 1884.52. Standard deviation they gave us was 1368.37. There were 675 males. And the X bar for females was $1,360.39. Standard deviation is $1,037.46. And we had 621 females in our sample. Our confidence level is, I gotta look to see what my confidence level was. I don't remember if it was 95. It was a 90%. Okay, so let's go to, so it should be 90 here. Pooled, yeah, put no for that, and then we can calculate. All right, so there you go. So there's our confidence interval, and notice our degree of freedom, 1249.21, and there's our confidence interval. Okay, so let's go ahead and write that down. So we got the degree of freedom was 1249.21, and then the confidence interval is 413.62, 634.64. There's our confidence interval. Let me show you option 2. So option 2, we need to subtract the sample sizes minus 1. So 675 minus 1, 621 minus 1. Okay, so 675 minus 1 is 674. 621 minus 1. 620. You choose the smaller of the two, so we're going to use this as our DF, okay? So DF is 620 for option 2. Look at the difference between that and then this one, right? Big difference. But when we look at the answer, it's not going to do that much of a difference. You'll see in the answer when we calculate it. And then we're going to calculate our T star. So our critical value. So we're not going to calculate it. We're going to find it. So you can look for it in the table. Based on the DF is 620. Now, actually, you can't use the table for this because 620 is such a big number. So since it's such a big number here, if you go to your table, you would have to use, you only have between 100 and 1,000, so you'd have to use 100. You have to use a smaller one, right? So then you'd be stuck with these. Now, and you could use that, and that's perfectly fine, but you're not necessarily limited to that. You can use the calculator and get that as well. So let me just put, if I did this on the calculator, how would you find the t-score for that? Let me show you that. Okay, so we're here. So if you wanted to find the critical value for 620 and just for that specific number, you go to stat again, and then go to the tests, right? And then you're gonna go, you're gonna do the, let's see, actually it's supposed to be on VARs. So second VARs, yeah, so second VARs, and then go to inverse T, and that's gonna give you the T score. So our area So remember, our area we're using a 90% confidence interval, which means we have 10% left over, and then divide that by 2, that's 5%. So we got 0.05 for the area, and then we have 620 degrees of freedom, and then we can paste that, and that will give us our t-score, negative 1.647. Okay, so I'm going to put that right here, negative 1.647. Now, what happens if I look this up on the table and I use df as 100, right? Well, if df is, because I'd have to use 100 instead of 1,000, right? So, so I'd use 100, and then I go to 0.05, and then I get 1.66. And it doesn't matter if it's negative or positive, but we're just going to write it as positive. So let me see, did I write it as negative? I wrote it as negative, but we're going to ignore the negative. But you'll get 1.66. But see, that's not that much of a difference, 1.647, 1.66. But it's still a bit of a difference, right? So if I use this to be more accurate, then let me use the formula for the confidence interval. Because I'm doing option 2 and it's taking up a lot of room, I'm going to do it down here. I'm going to do it over to the side, okay? Because I'm doing both options, and doing both is going to take more room. All right, so here's the formula: x bar 1 minus x bar 2. And then we got plus or minus. We got our t star. Then we got our standard deviation divided by, sorry, I'd have to do the square root one here. So which is going to be the square root of s squared 1 over n1 plus s squared 2 over n2. All right, so there it is. And then we're going to plug in the numbers, right? So we got x bar 1. Let me just see if I'm just going to reference that page with the values that they gave us in the problem. So we got 1884.52 minus 1360.39 plus or minus 1.647 times the square root, 1368.37 for the standard deviation squared, over 675 males plus 1037.46 squared divided by 621 females. Okay, and then you do that, and then we'll see what we get. Okay, so if you do this, you get approximately, this is just approximately 413.52, 634.72, something like that, 7271. So that's approximately what you get. Okay, which is pretty close to what we have here, so you can kind of compare the two side by side. Option 1 and option 2 are pretty similar because the degree of freedom is so high that it really doesn't make that much of a difference if you go from 600 degrees of freedom to 1,000, right? Because it's just such a high degree of freedom. Okay. All right, so now we got the confidence interval. I'm going to use option 1's results, and now we're going to conclude. Okay, so we are 90% confident oops, I used A instead of E, sorry about that. Confident, the interval from $413, or wait, is it, what's the context here? Yeah, okay. So $413.62 to $634.64 captures mu1 minus mu2 equals the true difference in mean summer earnings of male and female students. at the university. Okay, and then interpret the confidence level. Okay, so the confidence level is different. Okay, so we just interpreted the confidence interval. Now we're gonna interpret the confidence level. Okay, so the confidence level means that if we construct the confidence interval, if we construct a lot of confidence intervals from many random samples of 675 males, 621 females, we keep doing that. We keep constructing confidence intervals from those samples. About 90% of those confidence intervals are going to have or capture the true difference. Okay, so that's basically what we're trying to do. So if we took many, so if we took many random samples of 675 males, yeah, and 621 female students, or yeah, from the university, and construct confidence intervals. I guess we should say 90% confidence intervals. About 90% of these intervals would capture the true difference in mean earnings for males and females. Okay, all right, so let's look at the second question. In a study of heart surgery, one issue was the effect of drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were randomly assigned into two groups. One group received the beta blocker, the other group received the placebo. The pulse rate of each patient at a critical point during the operation was recorded. Here are the data in summary form. Okay. So we got the beta blocker, we got 30 people in each group. We got the mean, this should be the mean pulse rate between the beta blocker and placebo, and then the standard deviation. The distribution of pulse rate in each group is not normal. The use of two sample T procedures is still justified. Why? So, I mean, this is easy in the sense, we met the large sample condition, and so therefore we could use the two sample T procedure. Okay, so I'm just going to say the sample sizes for both groups are large. N1 is greater than 30 and N2 is greater than or equal to 30. Okay, and that's it. And then part B, construct the 99% confidence interval. Okay, so let's do the statement. So we say so we're constructing okay, so we're constructing a 99% confidence interval for mu1 minus mu2. How do we know it's mu1 minus mu2 instead of the mu difference, right? It's because these two groups are random. We have random assignment of two groups, okay, that are independent, beta blocker and placebo. They're independent groups. Okay, so that's how you know. All right, so where mu1 is equal to the true mean pulse rate of patients like the ones in the group taking beta blockers. And mu2 is the true mean pulse rate of patients like the ones in the group taking I could say in the group not taking it, i.e. placebo. Okay, we could just say the group not taking it, or you could say the group taking the placebo. All right, so we got mu1 and mu2, and then we're going to do the plan. Oh, let me just write this out. All right, now we got plan. We're doing a 2-sample t interval for mu1 minus mu2. And then we're going to write down the conditions. All right, random condition. We have 2 groups in randomized experiment. Okay, so 2 groups in a randomized experiment. They, obviously 2 groups, they're independent, they're randomized, all that. Okay. We got normal large condition. Oh, actually, let's do we're doing an experiment, so we don't have to do the 10% condition, okay? Don't have to check in randomized experiment. All right, and then we'll do the normal large condition. Okay, so normal large condition, we have N1 is 30 and N2 is 30. All right, so check for both of those, and then we can go ahead and do the do. All right, so again, I'm gonna do both options, but you don't have to do both options, okay? So option 1, I've already showed you how to do it on the calculator, so I'm just gonna tell you what you get for option 1, okay? So option 1, we're using the 2 sample. We have to write down the function that we're using. All right, oops, sorry, I put it on the, okay, so we got 2 samp t int and then as a result we have df is we get 57.78 for the degree of freedom, and the confidence interval is negative 10.64 comma 0.44. So that's a confidence interval. All right, and then we're going to show you what you would get for option 2. This one I will show you the step by showing you the calculation. So we would get 30 minus 1 equals 29. 30 minus 1 equals 29. So obviously the df is just going to be 29 because they're both 30. And then we're going to do the t star. Well, let's do the area. So the area, I forgot to do this in the last one, is 1 minus 0.99 divided by 2, which is 0.005. And then we can calculate the t star, or find the t star. So 0.005, and then df is 29. Okay, 29.005, right here, 0.005. So it's 2.756. 2.756. Okay, so then we can calculate the confidence interval. So again, x bar 1 minus x bar 2, right? All that stuff. So they told us 65.2 minus 70.3. Plus or minus 2.5756 times the square root of s squared, 7.8 and then 8.3. So s squared plus 8.3 squared over 30. All right, so there you go. All right, so if you do that, you get negative 10.83, comma 0.63. Okay. All right, which is a little bit off. If you look at the 0.44 and 0.63, that's quite a bit off, it seems. And then, but the 0.64, 0.83 was not too bad. But again, you can use either option because, technically both of them are options. However, I would go with the calculator and rest assured that that's the best calculation, okay? All right, so now let's do the conclusion. Again, you do not have to do both options on the AP exam or anything like that. But I do want you to practice doing the calculation for the for in terms of the homework. Okay, I do want you to at least practice a calculation and see if you can get what we get. All right, so conclusion. We are 90% confident, right? So we can, or 99%, sorry. The interval, and we're going to use option 1 for this, negative 10.64 to 0.44 captures mu1 minus mu2, which is equal to true difference in mean pulse rate of patients receiving a beta blocker during surgery and those taking a placebo. Okay, and notice that 0 is a plausible value in this confidence interval. 0 is within between these two numbers, which means that's telling you that we do not have convincing evidence, right? That the differences in means is not 0, right? So we don't have enough evidence because 0 is in our interval, so it's plausible for 0 to happen, which means it's looking less and less like mu1 minus mu2 cannot be 0 is what we're saying. Okay, so, or I think I said that reverse. Mu1 minus mu2, we have evidence that it can be 0. Sorry about that. I said that it can't be. It can be 0 because 0 is within this interval. I apologize. So since 0 is in this interval, we don't have convincing evidence against the fact that mu1 minus mu2 is 0. So we cannot reject. If we were to do a significance test, we would find using this methodology, we cannot reject the null hypothesis, right? Basically, if you're thinking about it in terms of testing. Okay. All right. So part C. Okay, so let's look at the part C. Interpret the 99% confidence level in the context of this study. All right, so remember what we said earlier. If we repeated this over and over again and we made multiple confidence intervals, then 99% of them will capture the true difference, right? So that's what we're going to do. Okay, so and remember we took 60 patients, 30 from each, right? 30 for each group. So if we took 60 patients and repeated many, and remember we randomly assigned them, right? So we repeated many random assignments of them to treatments of beta blocker and placebo, and constructed 99% confidence intervals about 99% of the intervals would capture the true difference in the mean pulse rates. For patients given a beta blocker or placebo. Okay, all right, that's going to do it for the video, guys. Hope you found this useful and informative, and as usual, I'll see you in the next one.